Hello, good afternoon. I am Daiyan, and my paper title is Fusion of Statistical Models at Denoiser to Restore Local Features from High Density of Salt and Pepper Noise. Presentation outline are introduction, proposed works, simulation and performance analysis, and conclusions. Introduction. What is digital image? A digital image is a representation of a two-dimensional image as a finite set of digital values called pixel elements or pixels. Digital images are prone to several types of noise. The noise may be introduced in several ways. For example, during image acquisition, light levels and faulty sensors, electronic transmission of image data. So what are the types of noise? Images are corrupted with Gaussian, salt and pepper, relay, or analog noise. We mainly focus on removal of high-density salt and pepper noise. What is salt and pepper noise? Impulse noise, where a certain percentage of individual pixels in digital image are randomly reduced into two extreme intensities. We have seen that in our picture, a segment of digital image where 1 to 7 pixel value is changes into 255, which is a noise. Problem statement. Astral medium filter was a reliable method to remove salt and pepper at low density only. But when the density is over 50%, the as details of the original image will not be preserved. The common drawback of adaptive filtering technique or all improved adaptive filtering techniques is that the noise pixels are replaced without taking into account local features when noise density is high. The major drawback of decision-based method is that defining a robust decision is difficult at high density. The median value will be 0 or 255. In such case, previously processed pixel is used for replacement. In fuzzy median filter, it produces blurring effect while removing high density of noise. Most of the nonlinear filters are failed to remove salt and pepper noise from pure black and white images. So our design goal is based on our improved filtering technique will be achieved to reduce high density of noise from digital images. Better noise suppression will be done. Preserve the details of image information. And we'll have high peak signal to noise ratio and mean structural similarity index. So our proposed algorithm should have some important features, reducing noise from corrupted image up to 90%. Faster, because median is counted only among the noise-free pixel. Local information is retrieved here as the window size increase is limited up to 7 into 7. So in our proposed algorithm, we start our filtering process with the 3 into 3 window mask. If the central pixel value is between 0 and 255, it is left unchanged. Otherwise, the noisy pixel is replaced by median filter of the mask. So here the median filter uses a list where it counted median value without considering 0 or 255. We can see in the diagram here. If the filtering mask contains salt and pepper noise more than 50%, The filter extends the processing mask from 3 into 3 to 5 into 5 to locate noisy free pixel. Again, if the filtering window contains certain paper noise more than 50%, the filter extends the processing mask from 5 into 5 to 77 to locate noise free pixel. So, if the filtering window contains certain paper noise more than 70%, then what will happen? It will take a temporary window whose size is 11 into 11 to assume the actual pixel pattern in the image, either pure black spot or white spot. There are two criteria. If the number of the individual pixel pattern 0 to 55 are above the threshold value, the filter take it as original pixel. The current mask threshold value is 70% pixel for the higher noise density. Otherwise, the processing pixel value changed into the trim mean value of the 5 to 5 mask. So here is the flowchart of our proposed filter. If we considering the visual analysis of our proposed algorithm, then we have seen that the linear image is noised with corrupted with 30%, 50%, 70%, 80%, and 90% of salt and pepper noise. And the noise is successfully removed by our proposed filter, where other filters did not show very good outcome. So in the removal of the density from the RGB image, the bubble still shows a good effect. So in the boat image, we have added 70% noise, and the noise is successfully removed by our proposed filter, where other filter did not show very excellent job. If we considering the performance analysis of our proposed filter based on the performance analysis metrics such as PSNR and MSNR, still our proposed algorithm shows a greater performance than other conventional filters. So this is our references which we have used to prepare our design our filter. And I am very thankful to our PhD supervisor, Dr. Ahsan Habib, Professor, Department of ICT, Mawlana Bhashani, University of Science and Technology, Bangladesh. Thank you all.